Yeah, yeah. Oh, of
Um,
course. As such things always are. Thank you.
okay, so I'm assuming everyone here has like put data in Magic before, so I'm going to kind of skip over some of the. I mean, I'm not going to talk in depth about the way that's structured or anything, but I guess the key thing that separates QDM data from like more conventional types of data or the different data types that we're working with, because we basically need to upload, like everything needs to be like archived and reproducible. Um, but there's kind of a couple different files and different processing steps that could go into making like a final data set. Um, and so this is kind of an overview of like the four main types of data that we're actually uploading. We're never really uploading anything like pre B111 because those files are obviously just way too big. But um, basically, we want to upload the context image as just a JPEG, but then also need to upload the original B11 image. And often you want to upload as well the BZ images just because they're a little bit more like intelligible and easy to like work with. And then sometimes if you're doing fitting, you also want to upload like the specific crop that you actually fitted, which would be what would let someone who's like going back through kind of try to directly reproduce numbers or anything. But these all need to be in, I can't remember exactly what it's called. It's like an abbreviated magic format. Um, yeah.
Yeah,
And so we'll
compact. Yeah.
Compact.
compact magic format, actually. Perfect. And so I'll kind of show some of that later. But we kind of need to do a bunch of things at once. Like I feel that the hardest part of this process is like, actually, let me just show also. So this is like a final magic file for our ALH project, right? And so some of this like is just far easier to just manually input. But once you get into any fitting, and in particular, because we're trying to coordinate all these images, we need to, first of all, link whatever measurement we're making to any image files that are used to produce it. And so we need this like files column. And then we also need to actually like rewrite those images at the same time in that correct compact magic format. And then also assemble a table of any images, like the context images that we're using. And if you make any like of the kind of cropped fitted maps and save those also need to be included here. And so what I've found in the process of making this, oh, and of course we want all of the details about whatever experiments we're doing.
And so all of that in your like specimen there, your like 10E, 10F are like different dipoles on a single map. Is that?
Yes, yeah, I was going to get into that a little later, but actually this would be
Okay.
a good thing to talk about now, because what we're kind of anticipating is that most people are going to just be using this. Well, I don't know, but I think it's probably going to be more common that people are archiving like whole images. People aren't doing this whole like inversion process. And so what we kind of came to with this work, which was based basically entirely on inversions, is that like, and this is a meteorite, obviously. So like the location and site are both just like our sample. And that each slice of it is well, a sample is a slice. And then the specimen is like the specific source that we're fitting repeatedly within the sample. So each source, as you're fitting, would have a unique like specimen ID that ideally you pick at the very beginning of your work and you hold on to that the entire time. I will say that makes everything, that would have made everything so much easier for sure if I'd done that. And I don't know that I'm going to talk a ton about the fitting side of things today. I can if people like want me to, but it's a little bit, it's not too different. But the I guess question here, I've never archived just like a plain map where there wasn't an inversion, but you still need to define a specimen like every time you write one of these rows so that you're connecting like, I don't know, you get all of the information about location and stuff.
Yep.
So
And specimen could just equal sample in that case.
yeah, that's probably going to be the easiest thing. So unless your sample has a super long name, maybe you want to shorten it. I don't know. It's up to you, but we could like decide on some convention if that's easier. I don't know, but yes. So the scripts that I've pretty much put together are kind of just coordinating this whole process, because you need to do, I guess I've kind of gone over this a little bit already, but like we need to put everything in the right format, put everything in, like give everything file names that are like findable, put it all in the right place, and then make sure everything written to the measurements table and the images table is correct. And so we've created a couple scripts that basically try to do all of this at once, rather than you're trying to like manually keep track of file names, which would be a lot more miserable. And for now, there's like 4 main scripts that one might wish to use. This is like the most kind of simple, and all it would do is if you give it a VZ file, it'll put it in the right format, and create the header. And then these 3 are actually doing that whole like full archiving process pretty much, with the exception of these kind of context tables at the beginning, which are just easiest to do manually. But these 3 will do that whole process just for different kind of data organization structures. So what I was planning to demo today is just this one, which would just be if you're trying to archive just images, there's no fitting involved. But then these are just 2 different options for archiving like fit data along with all the images, just depending on how you store it. Everyone has different preferences. Yeah, and I'll get into a lot more detail like when I actually do the demo, but just for reference, the way this is, you kind of use this. There's some like basic required things that you provide every time, just like where stuff is stored, whatever, what your magic contribution ID is, a name of an experiment specimen, that is basically always provided. But then these separate keywords, keyword arguments, there's a whole like range of available options that I have coded in now. And that's basically going to be equivalent to the method codes that, like that's how you'll pass method codes and like experiment details. So this is something that I would also like a lot of feedback on, because I know what I use in my work, like which method codes are in there now. It's not like the entire list from Magic. So it would be helpful to know what people use a lot so that I can code that up. Is this all relatively clear?
What's the dest? I guess you said you're going to explain it more, but that's
yeah.
Is that just a destination folder or something? Is it...
Yeah, like where you want, yeah, like where you want to save everything to, because eventually you want to zip it all and like, I guess for now, email it to Nick is still the way we're handling it.
Right, or a link.
Or a link, yeah, because these can get pretty big, so I guess maybe email is not the best move. Yeah. Okay, so these demos will also be, I mean, I'm still kind of polishing them. It's pretty much done, but I need to make sure everything is like, I haven't written any weird comments or whatever. But then they'll all be available in QDM Lab, and I don't know if we'll put them up anywhere else, but maybe. So yeah, I guess I'm just gonna go through this and stop me anytime if anything's like confusing. So this notebook is just demoing the process of uploading or like archiving kind of a single, like, it's not really a single image, but like a single kind of QDM data imaging step. Like, so this example is like, I think an ARM acquisition. And then I also have like later what you would do if you wanted to archive like a whole list of steps, like a whole demagnetization. So
you want to zoom in a tiny bit?
Oh, yes, that's a good point. Let me see.
We're just Yiming and I are getting like super close to this.
Yeah, sorry, I keep
No, you're good. I don't.
How do I even zoom?
I don't know. Can you just do like command plus?
I did try that and that.
Okay. Anyway, it's fine if it's fine if it's too good.
I mean, it is kind
We'll
of.
bring out a hand lens.
Am I crazy?
I mean, we can move.
Oh,
That's
yeah,
good,
right,
right?
right. Oh,
That's
that's
so
But then the
weird.
resolutions were.
oh, there, yeah.
Yeah, that's probably not easier actually.
This seems like it should be really, really easy to do.
No, we cannot. Ooh. All right, I think
Oh,
we can
Oh.
zoom in a little bit here. All right, screen.
is that too advanced?
Ooh, nice.
We figured out how to
Okay.
use how to zoom in using Zoom.
Using Zoom. Okay,
Oh,
cool. I think we're
is
good.
that something
You
I
can
can
zoom
do?
on your
No,
side.
no, but you can on our side we can zoom your screen, but it means we don't see the whole view.
Okay, as long as
We can
people
see where your
can-
cursor is. Anyway.
Oh, oh god. I'm just
Anyway.
worried about if we're recording this, is it gonna be
Oh, Sarah, I
not
just
at all viewable?
would it. If you go to the Home tab, your environment section, click Preferences. Is there Preferences?
Yeah, let me minimize the Zoom thing.
Second to right, Environment Preferences.
Nope, not that. Sorry. Okay.
And then should be a fonts in here somewhere.
Should be where? Fonts.
MATLAB fonts. Yeah, there we go.
Oh my gosh, that is itty bitty. Is that, can you
Ooh,
guys see that okay?
Yeah,
that's
like that.
good.
That's good? Awesome, okay, we'll do that. Cool, okay. Yeah, so this is just like showing the data that we're archiving. So for this example, like there's just some source. I think this is one of Roger's dystiolamine samples, but so this would be just the raw, like plain, well, it is bend, but plain QDM BZ map. And then if we upward continued it in the process of fitting, just for reference. Yeah, and so pretty much all I've done here is I'm setting just like the main file path. That, because this will just, I don't know, this is just how I organize things. You don't have to, but this is like the main stem I'm going to keep using to add things, and this is like the specific data file. And this is where things get a little bit more detailed, I suppose. So obviously we have just the, like all I know, like with that file, all that gives me is like the raw data, right? The context image and everything else, but I still need to set enough, give it enough information to actually like fill out the table in MagIC. And this is not that much information because there's not a lot of fitting involved. So I pretty much just need whatever my contribution ID is, which you would get from obviously initiating a contribution. And then since this is an ARM acquisition, I've just given it a name and a name for the specimen, which was just kind of like test1 T1. And I'm also specifying, since I'm going to be kind of archiving the upward continued image here, or at least I want to keep track of, well, I guess maybe this isn't fitting, so we don't actually need to, that's like left over from before. If I were archiving fitted data, whether or not I was uploading a fitted map, I would want to specify the upward continuation level. So that's just kind of.
And have you been doing the upward continuation one just as an image or also as a compact format where you're specifying the value at each?
You mean like, do I save the upward continued image as well?
Magnetic.
Or
Magnetic.
Are you saving the upward continuation in MagIC format or in image format?
I think what I typically do is I just specify the upward continuation level and then I save the raw map if someone wants to reproduce it. And I'll save, I mean, I don't know if I did this the entire time with the ALH project, but ideally one would also save the specific map that was fitted. And so I think what this does, it's been a while since I used it, or the fitting codes will go back through and like take the raw map, upward continue it, crop it, and save that crop. And that will also be saved as an LED image actually, but I don't save the upward continued version in the MagIC format just because there's no reason to, like you can reproduce that.
Is that
pretty
is
easily.
that model change a lot over time? Like if people are wanting to be able to reproduce that,
Mhm.
are they going to have to like go in some archive and see what the model was when you did that, or is it?
As far as
I'm
I
just
know,
wondering how
it
hard it
hasn't
is to
changed.
calculate that, like say 10 years from now.
I mean, Roger might know more. As far as I know, this hasn't changed since we started, or since I started, like probably years ago.
Yeah.
We've just been using the same.
So the math behind it should be pretty stable.
Okay. So people should be able to do that relatively easily if they need to.
The original citations like Blakely 2006 or something like that. But yeah, the math is given, decades before the QDM is.
Okay.
I can actually add, because for a lot of these like derived values, it's like the value name, the value, and then the like DOI of whatever paper. So I could save this in that format with the paper that, if that would be useful.
It's a the citation, the original math for the continuation is a textbook from 1996. So,
Okay.
Yeah.
Yeah, I mean, we save that parameter for the squid maps,
Yeah.
the squid magnetometer. So it might be useful to save that parameter and the reference, and then people will know how to do it.
Yeah, I can add that. I don't think it does now, but that's easy to change. Okay, and so the other things that I'm providing here is like the relevant method codes, and then the like AC/DC fields I'm using, and the field direction. And that's all I need in this case, since this is just an ARM position. And then I'm assuming this is my DOI. I should probably get rid of that before I put it up.
That's like your orchid, is that?
Oh, yeah.
Okay.
Sorry. My orchid.
Your DOI, that's better.
Oh man. Yeah, I'll make that more ambiguous before this is put up, but also because I didn't take this data, Roger did, so kind of stealing credit here, but yeah, and then the name of the specific QDM we used. Yeah, I mean, I know everybody works differently. I find that this is like the easiest way to keep track of everything, just like specifying all of them ahead and then providing it as a whole array. And then, oh, what do we have here? Oh, sorry, I made a change pretty recently. And it will kind of just make the files. Like I can just run this and it'll just make, like this is in front of your very eyes, So you can see it populating all that, and I'll open them in a sec once they're done, but it hasn't saved I could have done this ahead of time. I mean, I did, and I just deleted it because I feel like it's more striking if it's all, yeah. So you can see it saved the context image. These are saved with all of the header information. This is another reason why it's a lot easier to do all at once, since you only have to provide this information in one place. Yeah.
I mean, one thing that would be nice, but not necessary. I mean, if you could round those values, they'd be smaller files.
Oh, yeah, that's really easy to change, actually.
So you could sort of think about how many digits make sense, how many significant digits, but you probably don't need 8 or whatever.
Yeah, I do. That's something that I'm like currently specifying. Does anyone have a preference there to what I change it to? Will be enough.
I mean, I guess the one thing is just have enough, because I mean, you can run into it not being reproducible because of floating point rounding error.
Yeah.
So I would err on the side of more. But
yeah,
I know this is one of like Lisa Tokes' like huge pet peeves with AMS data is people round too much, so you can't actually reproduce when you're actually doing the tensor calculation.
Yeah, some things can be pretty sensitive. That's true.
Maybe I'll just add that as a keyword argument that one can change if they would prefer it be more or less
Well, if we
precise,
think
but
people are
I
gonna
can make the
put it
default
too
much more
small, then maybe we shouldn't let them.
We
I
can cap
don't
it.
know.
It'll crash your computer if you say you want more than 8 digits.
Yeah, as long as you're specified a number of decimals, like, in the first part of the floating point, right? Not like the actual digit or in Teslas or something. Because there are maps where it's significant down to the nanoteslas, and then there are also maps where the biggest number is hundreds of microteslas. So
Right, depends on how sensitive. Well, I mean, we can just leave it, I guess.
use like a relative precision for the measure.
I
How,
will look into
how is the
that.
scale of the image being preserved?
Let me see if I put units here. Maybe I didn't.
Yeah. You mean XY position?
That's a good question.
Oh, you got it. The field of view right there is in the description. No, I mean like the overall
Oh.
like of the image, the scale of the.
Oh, this is in like meters, right?
Yeah.
Oh, I see. Okay.
Yeah, these are all whatever the standard units in MagIC are.
Yeah.
I
guess I guess I was thinking of the LED JPEG.
That is just I think because the images are all like kind of connected here, right? Like you know exactly which corresponds to which one. You know the same field of view. Because we don't save that separate, but
it'd be basically you would just track. It'd be like the X max and Y max in this file effectively sets the scale of JPEG.
Just it's the same field of view.
You're missing a 0.
Where? Oh, here.
It should be 200. Yeah.
Why don't we change that?
Yeah.
Actually, I'll fix that later. Good catch. But yeah, that information is all there.
Now I have a question. Maybe I'm just confused now. Depends on your processing, how you bin the raw data. Would it have a mismatch of LED versus magnetic field map in terms of pixel?
Well,
pixel size.
Yeah, so it wouldn't match pixel to pixel, but it wouldn't otherwise because there's the size of the thing and the JPEG's not being saved, so a pixel equals ODMR spectra basically, right? So
like the number of microns should be I think you would need to
it'd be like the total X and Y, I guess.
Okay.
Yeah. So this should still be enough once it's corrected.
I apologize, I didn't ask you this earlier. But yeah, like where did that number of microns come from? Is it read in from the files?
No, this is I like supply this. This is just a description that I like include. So one could change this to include other information. And again, you would just supply this as like a keyword here.
Here's a question for people, right? Like in theory, those MATLAB files have information about the field of view, right? Because they have a pixel size and they have a size, right? X by Y pixels. So you could generate that number.
I think that'd be neat. Yeah, sort of, I know you've done a lot of great work here, Sarah, so it's like going into feature request territory, but it does seem like doing something like actually auto dropping a scale bar onto the saved out JPEG or something could be nice, in addition to what Roger's saying with
I was concerned more basic issue, which is just if you manually put in size and there's a internally defined size, they might not match up.
Yeah. So you're saying extract that from the
the original
map, and then automatically generate that string basically based on that. That seems like a good idea.
That seems really easy, and like we maybe already have a little helper code to do that in QDM Lab, or if we don't, we should. Yeah, I can do that. Oh yeah, so we can look at what it just made. Oh, let me close it. I don't know what's happening. It's fine. Okay, well, oh, it's still just running. Sorry, I left a little pause point. And this should be correct, but yeah. And so now this is just made like one row of the measurement file, right? It's also written the same row. Well, not, I mean, it's not the same information, but the corresponding row also for the images file. So you can track the context images.
Yeah.
So it'll do, it's like not more complicated to do it for like several experiments. It takes a little longer, but whatever. So yeah, and I'm supplying all the same information, just it will just like add that information. Yeah, I mean, is there anything people, this is like the basic idea, the way we're running it, but first of all, is there any other feature requests? I mean, you know, I don't have like thousands of hours to spend on this, but if there's simple stuff.
Is this demo script living in QDM Lab? Right.
It will be soon. I need to like proofread this because this is a more recent addition, because again, I really only use like fitting data, and so those demos have been around considerably longer than this specific one, but they'll all be in QDM Lab.
Oh, I'm just saying we can take this for a spin pretty soon, trying to that's what Roger highlighted for you, Minx. In Orthosite paper.
Make it. Yeah, so they're all in where is it? Data archiving, and then all the demos are here. There will be a few more after this is, you know, uploaded. One more. And there's all the demo data also. Right now they don't all include, I guess, the images, like the right answer, you know? Oh yeah, this is cool. So this would be the example of the fitted map that it saves. That would be nice to have a scale bar. That's a fair point. But yeah, I don't think any of this will be big enough to cause issues, so I can include the like what it should make in here as well. But yeah, this will all just be in this folder along with all the scripts that one would use. So
one question, this might also just get to a future request regime, but thinking about reproducing say somebody else's data and checking the data processing, is there a script that goes backwards?
Oh God, no.
Because this will be good for archiving, but then if that's the only thing that I upload, I will need to parse it back to MATLAB data.
This is true.
But I guess this is request to us. Oh, we can contribute, contribute to the follow-up script.
Yeah, I don't have any of that.
Yeah. So right now, if this is the only script that somebody attaches to the data statement, still a bit of gap to turn this back into BZ B111 map in MATLAB code, and then reopen this and reprocess.
If they're going to rewrite it in Python, is that going to be sort of the standard way going forward, or you think MATLAB people are like maintaining two code bases is always sort of a pain. What do you envision in the future?
I think after the Python version is stable and out, I think that's the only one that's going to be maintained.
Okay. So maybe, you know, sometime in the future, in a, you know, they could also write a backward script, or we can try to find somebody to write a backward script would be great. It may be in Python. I don't know.
But is it,
That
I
would
mean,
be
this is doable, right? Because we're making a matrix where we have all the information in the compact magic, right?
It won't be.
I just mean just doing it in, I mean, given that what we have right now is being able to do stuff QDM Lab and MATLAB.
Right. Yeah. I mean,
I guess there a technical hurdle I'm not seeing, which makes that hard.
I don't think so. Yeah, really do it.
I mean, that would be great to do, because then we could see which metadata maybe we're missing that's critical also.
Well, currently we have in PMAC, we have a DMAC GUI, we have a Tellier GUI. Eventually we could potentially have a QDM Magic GUI.
Yeah.
I'm already thinking about the buttons.
Just volunteer, just kidding. No, yeah, I guess one thing that may be relevant is you know, like a raw, like a B111 file, right? That comes out of the ODMR to B111 script definitely has more information than what's in here, right? It has the paramap built in. It has the induced map, right? It's always in there. It has it has a map of fit residuals. It has a map of the actual ODMR resonances, right? So it definitely, like, you can't go back from this to the original B111 file. I guess the question is, what do you need to go back to such that the, you know, a user would reasonably actually want to see that data and include all of that. Yeah, so I mean, at this point, it's basically just well, okay. Actually, Sarah, this is something I can't really I didn't think about earlier, right? So this is just a Faro B111 map, is that right?
Yeah.
Yeah, so
do we use the paramagnetic one to generate BZ or anything?
I mean, one could, and you know, it has been useful in places. Like your Martian meteorite, actually, right? The paramap shows the carbonates.
Yeah.
Nice.
I mean, I think it's not, it wouldn't be necessarily hard to modify this to be able to archive that as well, because it's really just like
yeah.
I'm specifying what I want to save, right? But
right. So I guess the question is, yeah, where will we specify that? And how will we specify in the magic keyword?
what do I mean? Just trying to remember what it already includes. Yeah, so it does say, I guess one would just swap out the BZ for whatever kind of other map. So that's easy.
Yeah, remnants, easy.
Yeah.
Okay.
We can change that. It is a little like, yeah, like how likely is it that somebody is going to use a given feature before they redo it all in Python is, I guess,
I suspect we want to. I suspect that the usage of the induced map would be significant.
Yeah, I can add that. That's there would probably just be an extra like keyword argument somewhere that just asks you which specific maps you want to archive.
Okay. Interesting. Yeah. Okay. Well, we can talk that out. But yeah, I guess that's definitely something I think we will want to implement. You know, even before we give it to any big enough level, just like information. This is the remnants.
Yeah.
We don't actually have right now. We just always.
I mean, this is not, I would really emphasize that this is not like complete code. This is the code that like would be sufficient for like my specific work, right? So I do still need like information like that, or again, like if there are like any of these like magic
right
properties that you're typically providing,
even in
like
this,
I need that information, right?
like what I mean is like even in this study, like somewhere it should actually say induced versus remnants. It should have that.
Yeah. But that's easy to change. I'm just also soliciting information for stuff that's like harder to change.
Okay. So which variable should that be? Like magic variable, like
Magic what?
In the
Right.
magic data model, do we need anything extra for those induced?
I think
Or maybe a method code? If you just put things in descriptions, you can't really search them in the data.
so
I see.
method code needs to be more specific,
Okay.
or well, I don't know. What do people think? The other place to do will be the experiment, because that's like, you know, that's saying like this map is blank, right? An experiment is a map, right? Sort of how we're thinking about it. Thoughts?
So we do have a LP QDM.I induced magnetization mapping.
Okay. So you have it.
So we have that already. You can add on there to label those measurements, right? Or those experiments.
The QDM implies remnants. I is specified as induced. That's fine.
Yeah. I mean, there's the QDM-R also, and we have the generic QDM. Generally, like the remnants is the default, I suppose. But if you want to be specific, you can do a -R, which might be useful to do in general.
That's good. Okay. Yeah. Okay, I guess back to this topic of the reverse code. Yeah. I would say maybe definitely do it, but down the road.
I mean, Ziming, would you want to write that code? Are you going to write that code yourself anyway, just so you can do it? And then we can, I mean, would you do that in Python or MATLAB? I mean, I'm just thinking that if that's something you're going to do anyway, maybe we can try to include that in here somehow, or you can work with Sarah to put it into this GitHub repository. I don't know if that's
if QDM.io's Python code is going to be a public repo eventually, I guess those viewing functions will be there, will be usable. But yeah, writing would be a good learning experience, looking at the data structure and these functions that are already there, the forward code, let's say. Anyways, so yeah.
Yeah. I'm just speaking thinking maybe for Sarah a little bit. She's put a lot of time into this, and so
Yeah, yeah, that's why I'm trying to like
Yeah.
offload that to somebody else. Or in the future, you know, it could be, I mean, I don't know about, you know, how this, what's the company name again, Roger? I forget.
QDM.io.
Q QDM.io. So maybe if, when they're, you know, doing their Python code stuff, then they could add that in there as one of the features.
Yeah, well, I think realistically that's gonna happen in like a year, 1 year time scale.
Yeah, so maybe 2.
Probably.
You never know.
QDM.io is more cash strapped than one would imagine.
Okay.
I just
All right. Well,
No,
Zima, if you do decide to do that backwards code, let me know, and we can figure out how to get that included so other people can use it.
mhm.
Could be one of my IRM projects.
Could
Yeah.
be.
Great. Um, yeah, any other thoughts about this?
So I guess basically these example codes are going to be, or these scripts. We'll have a few of these different example scripts for different types of ways people can do things, and that'll be, that's the main way people sort of interact with the rest of the functions. And so most people will just fiddle with this script for these parameters that they're inputting, and then the rest of it hopefully will work well.
Yeah.
All right,
Yeah,
Roger. I'll send you an email. I'll try to, it would be nice to get a couple more examples like you said in. Who, I mean, you said Andy Biggin, so who, I mean, one of his grad students or somebody would learn that over there, or what do you think?
Yeah, I think once we have a final version of this, we can just send an email to, I think, yeah, like Daniel Fowler is the first author on that.
Okay, yeah, he's at Florida now, I think.
And then just say, yeah, try writing this, please. For a moment.
Okay.
And in a IRM context, I mean, I guess like the idea is that people are coming for the magnetic microscopy fellowships. We basically just sort of teach this as like a critical part of the workflow, basically.
Yeah, I think that'd be the idea.
Yeah.
So I guess that'll take some like documentation on our sort of side of things. But
Yeah, there's a
Yeah.
couple of documentation things we need to catch up on, so this would be one to add to the pile.
Yeah, it
sure.
kind of got me thinking too about how to deal with MFM images.
Yeah, right.
Yeah. Well, I guess just to review, so Sarah, the edits we want to make before it even goes out to Biggin and Brenner and people is we want to like internally calculate the dimensions, right? We want to, I mean, this could even just happen in your sort of comments and notes, but yeah, like tell the user where to specify the induce versus remnant.
Yeah. That'll be a keyword.
Yeah. Is that it? People remember other things? We need
Anything else?
I just wanted to add, I think a couple of weeks ago, I saw Sarah's commits to the repo and I was quite excited about it. So I just want to thank you very much for that.
Yeah, it's been great.
Finally, there. Yeah. Anyway, it's great. Awesome.
Thanks.
Well, thanks for everybody coming, and it'd be great we'll see some more data coming up in the MagIC repository for people to work on.
Fantastic.
Thanks, everybody.
All right.
Guys.
Right.
Right.